Hi everyone, in this video we look at another problem involving inverses of functions. So here it says for the function g of x is equal to x minus 2 squared plus 1, determine an equation for the inverse of g of x. So we already looked at in the previous video that when we find the inverse of a particular function, we swap the x and y values. So that means that we'd put g of y, we'd let g of y be equivalent to x, and let's actually put y into the function for g of x, and we'll get that x is equal to y minus 2 squared plus 1. So we swapped x and y, and now we're going to solve for y. I can solve for y by first subtracting 1 from both sides of the equation. So I get that x minus 1 is equal to y minus 2 squared. I can take the square root of both sides of the equation. I have to remember that I have to add a plus or minus symbol to the left side of the equation anytime that I take the square root of both sides. And the next thing that I can do is I can add 2 to both sides of this equation to isolate for y. So I get that y is equal to plus or minus the square root of x minus 1 plus 2. Now, an important thing to note here is that for a single input of x, let's say I input x is equal to 5 into this equation, I'm going to get out 2 values for y. So in this case, the inverse of g of x is not a function. So when we swap x and y, we actually get, for a single input here, we get 2 outputs for y. So the inverse is not a function. Now, an important thing to realize, to identify, is that I can't write that f inverse of x is equal to plus or minus the square root of x minus 1 plus 2, because this is notation that we use for functions, and since the inverse is not a function, I can't use this notation here. So I wouldn't write f inverse of x, since that implies that the inverse is a function, and it's not. The inverse here is simply a relation. Here it says sketch the graphs of g of x and its inverse. So let's go ahead and we can do that. And if we first sketch g of x, this is a parabola with vertex at 2, positive 1. Whoops, sorry, 2, positive 1 is right here. We can follow the step pattern of the parabola. We can go, the step pattern is, since the a coefficient is 1, we'll go 1 over 1 up 1 over 1 up 3, and then the next step would be 5, so that's off the graph. So next I can reflect these points about the axis of symmetry and draw a smooth curve through all of these points. And that is the graph of our function g of x. Next I'll graph the inverse relation. And an important thing to note is that to find the inverse, you can actually, I could graph both of the branches of this function. So I could graph plus or minus root of x minus 1 plus 2. An easier way to do this is just to swap the x and y values of the function g of x. So if this point here is 2, 1, then 1, 2 is going to be on the inverse. And I can go ahead and I can do that for all of the points on g of x. So I'm just swapping the x and y values of all of the points of g of x. Lastly, I'll draw a smooth curve through, a relatively smooth curve through all of these points. Okay, let me try again. As you can tell, I'm not an overly artistic person. Okay. There we go. That's a little bit better this time. And let me connect. Okay, there we go. So this is the graph of the inverse relation, and I can label it as y is equal to plus or minus the square root of x minus 1 plus 2. Graphically, we can see why the inverse is not a function, because if I draw a vertical line through the graph, it fails the vertical line test. So the inverse is definitely not a function. An easy way to tell whether a function, whether its inverse is going to be a function or not, is to look at the graph of the function. Okay, so we already talked about how the inverse of a function, or the graph of the inverse of a function, is going to be a reflection about the identity line. So here let's graph the identity line. It's just the line y is equal to x. So let's go ahead and we can graph that. So this is the line y is equal to x. It's the identity line, and you can see that the inverse is a reflection of g of x about the line y is equal to x. It's pretty obvious to see that if you reflect g of x, if g of x fails, or if you draw a horizontal line through g of x, and you can see that the horizontal line passes through the graph at more than one point, that its inverse is going to fail the vertical line test. So a really fast way to tell whether a function is going to have an inverse that's not a function is to see whether it passes or fails the horizontal line test. If I draw a horizontal line through my function and it passes through the function at more than one point, like it does here, then its inverse will not be a function. Its inverse will fail the vertical line test. So here it says, is the inverse a function? And no, the inverse is not a function. So no, the inverse is not a function. Next it says, what do you notice what do you notice about the domain and range of g of x? And it should say and its inverse here. So that's a small typo. And its inverse. Oh, and I also spelled notice wrong. So this should say notice. There's another typo there. Okay, so what do you notice about the domain and range of g of x and its inverse? Okay, well, let's look at the domain of the domain and range of g of x. So for g of x, the domain was equal to, let's see here, since it's a quadratic function, the domain would just be the set of all real numbers, and the range would be equal to the set of all real numbers, such that here, let's see, y has to be greater than positive 1. Y is greater than or equal to positive 1. And then let's look at the inverse. So let's write this as g inverse. So for the inverse of g of x, the domain, let's look at the graph. The domain is x has to be greater than or equal to positive 1. So it's the set of x in the real numbers such that x has to be greater than or equal to positive 1. The range, well, if you look at the range in the graph, the range is just the set of y in the real numbers. So the range is the set of y in the real numbers. So in the question it says, what do you notice about the domain and range of g of x and its inverse? How are the domain and range related? And let's think about what what our function g of x does and what the inverse does. Well, remember that if a comma b is on the graph of f of x, then b comma a is on the graph of its inverse. Because to find the inverse, you just swap the x and the y values. And then, whoops. So what can we conclude here? Well, let's look at let's examine the domain and the range of g of x and its inverse. Notice that the domain and the range for the inverse have just swapped. So the domain is the set of all real numbers, or the set of x in the real numbers, such that x is greater than or equal to 1. The range of g of x was the set of y in the real numbers, such that y is greater than or equal to 1. So the range became the domain, and the domain became the range. And that makes sense because the inverse, to find the inverse, we swap the values for x and y. So we can write that out, and we can say the domain and range, whoops. Let's write the domain of the inverse is the range of g of x, and the range of the inverse is the domain of g of x. So you can see that the domain and range for the inverse are just switched. So if you're asked to figure out what the domain and range of the inverse are, and you know what the domain and the range of the function g of x are, you can literally just swap the domain and range. In the next video, we'll look at another example where we are given a parabola and we're asked to restrict the domain of the original function so that its inverse is a function.